Hello and welcome. I am Dr. Pauline Fu. In this video, I will present hypothesis testing. Objective 1. Determine the null hypothesis and alternative hypothesis. 2. Explain type 1 error and type 2 errors. 3. State conclusions to hypothesis test. Let's take a look at an example. Claims regarding our characteristics of a single population. In 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. So this one is a statement about percentage of people doing volunteer their times for charity work. And in this example, the researcher believes that the percentage is different from today, means the percentage is not 62%. Okay, so we have two cases. One case is that the percent is 62%. Another case states that it is not 62%. So, okay, so those are the examples of claim regarding a characteristic of a single population. Another example. According to study published in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. So the average phone call is 3.25 minutes. A researcher believes that the mean length of the call increased since then. Again, you have two cases. One case claimed that the average cell phone call is 3.25 minutes. The other case states that the average phone call is longer than 3.25 minutes. Okay. So two cases, we say one is null hypothesis, the other is alternative hypothesis. For null hypothesis, we use H0. Hypothesis test is targeting population. We use mu represent population mean. And one statement said population mean equal to 3.25 minutes. Alternative hypothesis, we use H1. H1 usually is the opposite of H0. But when you have keyword increase, H1 means average greater than 3.25. Okay, so that is a null hypothesis, mu equal to 3.25. Alternative hypothesis, mu greater than 3.25. Translate to plain English, the null hypothesis said the average phone call is 3.25 minutes. The alternative hypothesis said the average phone call is greater than 3.25 minutes. So now let's look at the previous example. Okay, so in this example, what we want to decide is null hypothesis H0 and alternative hypothesis H1. So this one said, again, hypothesis is always targeting population. We use P represent population proportion. So P equal to 62%. Alternative hypothesis said it is different from 62%. So population proportion is not. Different means it is not 62%. And translate to plain English, the null hypothesis is 62% of American adults volunteered their time for charity work. Alternative hypothesis said it is not 62% of American adults regularly volunteer their time for charity work. So now let's look at another example. Use an odd manufacture process. The standard deviation of the amount of wire put in a bottle was 0.23 ounce. With new equipment, the quality control manager believes the standard deviation has increased. So this hypothesis test is about population standard deviation. We use sigma, Greek letter sigma, represent population standard deviation. The null hypothesis said sigma equal to 0.23 ounce. Translate in English means the population standard deviation is 0.23. Alternative hypothesis H1, because we have keyword decrease, so we should use sigma smaller than 0.23 to reflect the fact that it is decreasing. And translate into English, it is said the population standard deviation is less than 0.23. Okay, so this is this example. So far, we did 3 examples. This example is about hypothesis test for population standard deviation. And the cell phone, this example, hypothesis test for population mean. And this percentage is hypothesis test for population proportion. Okay. So what is a hypothesis testing? It is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. The hypothesis test is to draw conclusions about the population based on sample data. Steps in hypothesis test. You want to make a statement with regard to the nature of the population. It is about the proportion, or it is about the mean, or it is about the standard deviation. Okay. And when you make statement, you have to express your statement in either H0, null hypothesis, and H1, alternative hypothesis. Next step, you collect sample data to test the statement. We'll talk in detail about step 2. Okay. Finally, you analyze the sample data to assess the plausibility of the statement and to make statistical conclusion and managerial conclusion. We already introduced the null hypothesis. We use H0. It is a statement of no change. No change means equal, okay? No effect or no difference. That is HO. And alternative hypothesis H1, okay? H1, usually it is about change not equal, or smaller than, or greater than. So H1, always one of these three symbols, nothing else. H0, in our textbook, always use equal sign. Other textbook may also use smaller equal, greater equal. Could also be used as H0, okay? And H1 could be one of these three symbols. If you're confused, how do I know which one is H0, which one is H1? Think about the notation. H0 means no change, okay, no change. So it is always this equal sign. Okay, if you see equal, that is H0, no hypothesis. And alternative hypothesis, it is not equal, or smaller than, or greater than. Because alternative hypothesis has three situations. See, when H1 not equal. When H1 use not equal, we said this is a two-tailed test. When H1 has a smaller sign, this is a left tail test. And when H1 has a greater, we call this is right-tailed test. If I use graph to illustrate this process, the two-tailed test, picture like this. This is two-tailed test. You have a left tail and right tail. And the left-tailed test, you just have left tail. And the right tail test, you just have this right tail. So that is the pictures corresponding to three different situations. Now let's look at this example. For each of the following claims, determine the null and the alternative hypothesis, and also state whether the test is a two-tailed, left-tailed, or right-tailed test. Okay. Question A. In 2008, 62% American adults volunteered their time for charity work. A researcher believes that this percentage is different today. See the keyword different. Okay, so the null hypothesis H0, population proportion P equal to 62%, and alternative H1, population proportion P not equal to 62%. Because H0 has not equal, this is two-tailed test. This is a two-tailed test. You have left tail, you have right tail. Okay. And question B, we actually already did those, but to quickly review. According to a study published in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. A researcher believed that the mean length of the call has increased. Okay, so H0 always regarding to something equal. Because this is population mean, we use mu equal to 3.25. And H1 has three situations, equal, smaller, greater. In this case, you have keyword increase. So mu is greater 3.25. Because H1 is greater, it is right tail test. Right tailed test. And the last one, using an old manufacturing process, the standard deviation of amount of wine put in a bottle was 0.23 ounce. With new equipment, the quality control manager believes the standard deviation has decreased. So this is the standard deviation. Regardless, H0 always equal. We use sigma represent standard deviation. So sigma equal to 0.23. Okay. The keyword decrease means H1 sigma smaller 0.23. Because H1 has smaller, this is left tail test. Left tail test. Okay. So that is the language of hypothesis test, null hypothesis, alternative hypothesis. Next, we are going to introduce type 1 error and type 2 error. Let's think about when you test something H0, the result of H0, null hypothesis. The result of H0 could true, could false. Any statement, there are only two outcomes. Either this statement is correct or this statement is wrong. You don't have third options. Okay. So if a statement is correct and you reject something that is correct, you are making mistake. That mistake is type 1 error. Type 1 error. Okay, something is true, but you reject something that is true. You are making type 1 error. Okay. Now let's look at this situation. If a statement is false, you reject the statement. You reject something that is false. You did correct thing. And this combination, if null hypothesis is true, you do not reject the null hypothesis. Something is true, you do not reject. That's correct. And this situation, maybe I'll make the situation clear. There is actually a table here. Okay. Yes, for situation. Okay. Here. And this situation said, when null hypothesis is false, you do not reject HO. You are making mistake. This time, you are making type 2 error. Type 2 error. So that is the type 1 error, type 2 error. So now let's take a look at the example. Okay. For each of the following claims, explain what it means to make a type 1 error. What would it mean to make type 2 error? Okay. So this statement, 62% American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. When the question asks you if this is a type 1 error or type 2 error, or identify type 1 error, type 2 error, strongly suggest you write down H0 and H1 first. You must write down H0, H1. Do not just read original statement. You need to write down what is null hypothesis, what is alternative hypothesis. Very important first step in identify type 1 error, type 2 error. Okay. So we already know H0 is population proportion equal to 62%, and H1 population proportion not equal to 62%. Okay, and now what is type 1 error? Okay, type 1 error means the population proportion is 62%, but you conclude the population proportion is not 62%. You are making type 1 error. I repeat, type 1 error is you said the population proportion is not 62%. As a matter of fact, the population proportion is 62%. You are making type 1 error. Okay? And now, what is the type 2 error? Type 2 error means the population percentage is not 62%, but you are saying it is 62%. You are making type 2 error. I repeat, type 2 error means you are saying the population proportion is 62%. As a matter of fact, the population proportion is not 62%. You are making type 2 error. Okay. So this is this example. And question B. We already did this H0, H1 for question B. So quickly review. What is hypothesis test? H0, H1. H0 said mu, population mean is 3.25. Alternative, mu greater 3.25. So type 1 error, means you claim the population mean greater than 3.25. As a matter of fact, the population mean is 3.25. You are making type 1 error. Okay, type 1 error. And type 2 error, the population mean is greater than 3.25, but you claim the population mean is 3.25. You are making type 2 error. So I repeat type 1 error and type 2 error for this question. Type 1 error, the population mean is 3.25, but you claim the population mean greater than 3.25. You are making type 1 error. Type 2 error, the population mean is greater than 3.25, but you are claiming the population mean is 3.25. You are making type 2 error. Okay, I repeat type 2 error. The population mean is greater than 3.25. However, you claim the population mean is 3.25. You are making type 2 error. You need to practice, okay? The base of type 1 error is based on this table here, okay? All right. So let's introduce our new notation. We use alpha, represent the probability of making type 1 error. Okay, remember what is type 1 error? You reject H0 when H0 is true. Okay, and we use beta represent type 2 error, the probability of type 2 error. Remember what is type 2 error? You do not reject H0 when H1 is true. Okay. We also introduce the level of significance alpha. Okay, the probability of making type 1 error is chosen by researcher before the sample data is collected. Popular alpha, 0.05. Most people will choose alpha equal to 0.05. Sometimes people will choose 0.01 or 0.1. Those are 3 popular choices for alpha. Alpha has a name, level of significance. It is the probability of making type 1 error. What is the relationship between alpha and beta? Remember, alpha represents the probability of type 1 error, beta, the probability of type 2 error. The relationship is, as the probability of type 1 error increase, the probability of type 2 error decrease, and vice versa. Means, as the probability of type 1 error decrease, the probability of type 2 error increases. All right, example. According to a study published in March 2006, the mean length of a phone call for a cellular telephone was 3.25 minutes. A researcher believed that the mean length of the call has increased. Question A. Suppose the sample evidence indicates that the null hypothesis should be rejected. State the wording of the conclusion. Okay. So suppose the sample evidence indicates that the null hypothesis should be rejected. State the wording of the conclusion. So the wording of the conclusion should be the average mean length of a call has increased. That is conclusion. If you reject H0, you must accept H1. H1 said the average is increased. Remember this situation, we have H0, null hypothesis mu equal to 3.25, and H1 alternative mu greater than 3.25. Okay, so if you reject null hypothesis, you have to accept H1, means the average phone call increased greater than 3.25. Now, question B. Suppose the sample evidence indicates that the null hypothesis should not be rejected. State the wording of the conclusion. If you do not reject null hypothesis, that means null hypothesis hold true. Okay, that means the average is 3.25. Okay. So the solution is here, posted here. Okay, I pause for a moment. You can compare the question and the answer. So this is B. Okay. In summary, what I did in this video, I introduced the basic concept of hypothesis testing. Specifically, I introduced the null hypothesis H0, alternative hypothesis H1. I also explained type 1 error, type 2 error. Finally, we have some examples. Okay, hope you learned something from this video. Thanks for your time. I look forward to see you next time.